Good morning to all of you. I welcome you to this session of Big Data Analytics. And in today's session, we are going to discuss about Hadoop and its ecosystem. So let's begin today's session. As we discussed in our previous class, that Hadoop ecosystem has got many components having different functionalities. So the components are HDFS, Hive, Pig, Yarn, Flume, Scoop, Uzi, Zookeeper, Mahawk, and Ambari. So I'll be discussing these components one by one, and then I'll be discussing about the use cases of big data. And after that, we'll be discussing the various installations that we require to run our commands and analytics. Okay, so let's begin with HDFS. Okay. HDFS is Hadoop Distributed File System. Okay. It is a file system, in which huge, big files are stored, and then later on they are analyzed. Okay. So it is used for managing big data sets with high volume, velocity, and variety. What is this volume, velocity, and variety? We'll discuss soon. Then it is HDFS is a master-slave architecture. Okay, it's a master-slave architecture where master is the name node and slave is the data node. What these name node and data node mean, that we'll learn soon, right? These are the processes of HDFS. So where the name node is the master process and data node is the slave process. Features of HDFS we're going to study in detail. Architecture we are going to study in detail. Features are scalable, reliable, and it uses commodity hardware. I discussed with you people about commodity hardware. It means cheap hardware which is prone to frequent failures. And HDFS is well known for its big data storage. Next is Hive. Okay, so Hive is a high-level query language. So you can put your queries and get the results. Queries for analyzing data, and you can get results in Hive. Okay, and it is a sort of a data warehouse. Okay, a data warehouse is where you keep on piling up huge amounts of data, and then you can analyze it slowly. That means you're not analyzing it live. Okay, you first store it and then you analyze it, and it provides something known as data summarization, query, and analysis. Okay. So historically, it was developed by Yahoo and later made open source. Since it's a part of Hadoop, so it's an open source technology, and it has a interface just like SQL that you've learned, and it is known as the Hive query language (HQL). Okay, and it provides something known as partitioning and bucketing for faster data processing. That's about Hive. The next is Pig, which is another high-level language built on top of MapReduce. This is important. That means while in the foreground you are running Pig commands, in the background the architecture is based on the MapReduce. We'll be studying these things in detail, so don't bother too much about them right now. And again, it is used for analyzing large data sets with simple data analysis programs. That means we have a very good large set of operators in Pig, which helps you to write simple programs, but effective data analysis can be done with that. And this is known, Pig is known as a data flow language. That means if you start with the one command, then a flow is made. The output of one command is an input to the next command, and so on. Pig is also very well integrated with Python. Okay. Again, it was initially developed by Yahoo and later made open source. Okay. We're going to study Pig in detail. Okay. Complete detail. Then Yarn stands for yet another resource negotiator. Okay. So I told you initially the data analytics algorithm was known as MapReduce. Yarn is MapReduce version 2. Okay. So there are two major processes in Yarn. They are known as resource management and job scheduling or monitoring. Okay. And in MapReduce, they were having some different name, but since we'll be using Yarn version 2 or MR version 2, so we'll be using processes or daemons with the names as resource manager, node manager, and application master. So just to connect things, I told you HDFS has got two processes, basically the name node process and the data node process. So two processes to run your distributed file system. There is another distributed file system process or daemon which is known as secondary name node. Okay. So three processes we have for our distributed file system: name node, data node, and secondary name node. Okay. And when we talk of analytics, then we have two processes mainly and one environment controller. So there is a resource manager, there is a node manager, and there is an application master. So whenever we start our cluster, okay, whenever we start our server and a cluster is started, all these processes must be up and running so that we can do data storage and data analysis. Okay, I hope it's clear. Then Flume is an open source tool for collecting, aggregating, and moving huge amounts of streaming data from an external web servers to a central store, such as HDFS. Okay, and it is highly available and reliable service. So company, you see a scenario where a company has millions of services that are running on multiple servers producing lots of logs. Okay, so logs, I told you, is recording process from its initial state to a final state. So there are millions of services which are producing lots of logs. So in order to gain insights and understand customer behavior, we need to analyze these logs altogether. Okay. So in order to process logs, a company requires an extensible, scalable, and reliable distributed data collection service, which must be capable of performing the flow of unstructured data, such as logs, from source to a system where they'll be processed, such as in HDFS. See, we are not going to discuss Flume in detail, but we must know something about it. So it is another service which is being used by companies to uh, pick out important information from the logs that are generated while the services that they are providing to their customers they are running. Okay, so we see millions of services that are there which are producing large number of logs. To analyze those logs or to gain insights into those logs, we must we must process them. Okay, so Flume helps to do that. Next, Scoop is a tool designed for efficiently transferring bulk data between Apache Hadoop and external data stores such as relational databases. Okay. So when we talk of structured data, we talk of Scoop. When we talk of unstructured data, we talk of Flume. Okay. Remember this differentiation between Flume and Scoop. Okay. Then there is a workflow scheduler system. So see, we have got a lot of jobs in Apache Hadoop. While we are storing data, we are processing huge amounts of data. So when to move, when to do the processing, when to combine the results, all this is managed by the workflow scheduler or a workflow manager known as UBUNTU. Okay, and it uses something known as directed acyclic graphs. Okay, and it manages the environment. Actually, since we are not going to learn it, so I won't be going into much detail, but it is present whenever you are installing a cluster. UBUNTU is there to manage things, and it is scalable, reliable, and extensible. By scalable, I discussed with you in the previous class also. By scalable means that we can keep on adding machines to a cluster to improve the performance of the cluster. Then the last three are the Zookeeper, the Mahout, and the Ambari. Okay. So when we need to manage the configuration information of our cluster, okay, then we take the help of Zookeeper. Okay. Mahout is a very important machine learning library. Okay. So to do the predictive analytics, there is the Hadoop ecosystem component known as Mahot. Okay, and it is very important while you are dealing with predictive analytics like machine learning and all. So this is the machine learning library of Hadoop. And then Ambari, you see, is designed to make Hadoop management simpler by providing an interface for provisioning, managing, and monitoring Apache Hadoop clusters. So when you need to do the monitoring of your clusters, then you can take the help of Ambari. Okay. So that is a brief, introduction to Hadoop ecosystem components, and I'm sure that you have got some insight into it. So let's have an insight now. Like, we have been talking about big data for two classes now. One class was yesterday, and today again we have started discussing about big data and what it is. Okay, so you see, there are some things that are so big that they have implications for everyone, whether we want it or not. That means, like, if you are surrounded by big data, okay, then it will have some implications. You cannot escape it, whether you want it or not. You'll be a part of that big data environment, right? So it is that thing, which is completely transforming the way we do business and is impacting most other parts of our life. I think you agree with this. It is completely changing the way we used to work, the way we used to study, the way we used to conduct our meetings, the way we used to, sell things, buy things. It is totally changing that, right? So the basic idea behind it is that everything we do is increasingly leaving a digital trace, which we can use and analyze. And obviously others can also use it and analyze it. Okay. So big data therefore refers to our ability to make use of the ever increasing volumes of data. There's a huge volume of data. So we can benefit out of it, right? We can benefit out of it. We can make use of it for our betterment. Okay. One important fact, see, from the dawn of civilization until 2003, human mankind generated 5 exabytes of data. The exabyte, remember, is 10 raised to power 18. So now we are producing 5 exabytes of data every 2 days. So just see the volume of the data that we are dealing with. Okay, so we can have activity data. Okay, like if you're listening to music or reading a book, these things are now generating data. Okay, digital music players are there, e-books are there. They are collecting data on your activities. Your smartphone collects data on how you use it, and your web browser collects information on what you are searching for. Okay, whatever you are doing is leaving a digital trace, is leaving some data for others to analyze for their benefit. So similarly, your credit card company collects data on where you shop, and your shop collects the data on what you buy. So it is, it's very difficult to imagine any activity which does not generate data. We discussed this yesterday also, that we are flooded by data, we are surrounded by data. Everything around us, anything around us is data. Okay. So conversation data, very important. Our conversations are now digitally recorded. I am recording this meeting right now. Okay, initially we were just recording emails, but nowadays most of our conversations leave a digital trail. Just think of all conversations we have on social media sites like Facebook or Twitter. Okay, even our phone conversations are now digitally recorded. Okay, then we have the photo and the video image data. Okay, just see how many pictures we take on our smartphones or digital cameras. We upload and share hundreds of thousands of them on social media sites every second. Imagine CCTV cameras taking video images, and we upload hundreds of hours of video images to YouTube and other sites every minute. Okay, then sensor data is there. Okay, the GPS systems. Okay, it is monitoring your every position. Like if you are driving a car, okay, how can GPS tell you that you reach your destination in 2 hours? You reach your destination in 1 hour. It is monitoring, the satellite is monitoring like what is the road condition ahead, what is your speed. Okay, so based on that, it calculates, some algorithm is there and it calculates and tells you. So if you just speed up, it will tell you now 45 minutes are left. If you low down your speed, then it will tell you you'll take 1 hour 10 minutes to reach your destination. That is the sensor data, right? Then Internet of Things data, like we have alarms, smart watches, smart fridges, washing machines, traffic sensors, so many things are there. Now with this datafication, we have big data, which is often described using the 4 V's. So this is a old PDF. So we have got, this number of V's is continuously increasing. Okay, and initially we had the 4 V's of big data. That is the volume, the velocity, the variety, and veracity. Okay, so volume is the amount of data that is being generated. Velocity is the speed at which it is being generated. Variety is that it is coming in different shapes to you. It is coming in form of sound, image, video, audio, like a lot of variety is there. And veracity is something, which is very important, because if we are having such a huge amount of data with us, then we must be very clear that how much out of it is true, is veracious. Okay, veracity means truthfulness. So we must be very careful with that. Okay, that is one characteristic of big data which must be taken care of. Like you are having so much information coming to you on social media sites. What is true out of it, what is fake, that is very important, especially in terms of when we talk of big data. Okay, so this is a small description of volume. So we talk of terabytes initially, but now we have zettabytes and brontobytes and so on. Okay, so huge volume of data. Velocity means the speed at which the new data is being generated. Okay, so you see the social media message is going viral in seconds. Okay, and technology has made it possible for us to analyze the data while it is being generated. Not that while when it is created, then we'll store it, then we'll analyze it. It is being analyzed while it is being generated. Variety means different types of data that we can use. Okay. In the past, obviously, we were only focusing on structured data that neatly fitted into our tables or relational databases, such as the financial data, right? And now you see 80%, I would say 90% of the world's data is unstructured. Text, images, video, voice. So with big data technology, we can analyze all this data, which was not possible before with the traditional relational database management systems. Okay. And veracity refers to the trustworthiness of the data. Okay. So you understand that a lot of fake posts or messages are floated. So we should not be just believing them. We must first verify its truthfulness. Okay. And then, like fifth one has already come here after the first four. The fifth one, the most important one, is the value which this data is going to provide to us, how it is going to benefit us. Okay, so that's very important. The fifth V, the value. Okay, so now we have volume, velocity, variety, veracity. Okay, and then what is the value out of it? The 5 V's we have now. Okay. So let's see if we can see the 7 V's in one view. Okay, I just made a small, yeah, I hope you can see it on screen. So volume is there, okay, then velocity is there, okay, okay, variety is there, okay. A new one, variability. So you see variability is different from variety. See a very good example here. Like if you have a coffee shop offering 6 different blends of coffee, but if you get the same blend every day and it tastes different every day, that is variability. Okay. The same is true of data. That if the meaning is constantly changing, it can have a huge impact on your data homogenization. Okay. I hope you understood this variability. Then veracity is all about making sure that the data is accurate. That's very important concept, veracity. You should not trust anything that you receive immediately, especially from the social media sites or from any source, because people are spreading a lot of fake information to create problems in the society. Okay. Then obviously visualization is very critical in today's world. So the data that we are getting, that we are analyzing, if we can use charts and graphs to visualize it, that's very important feature of big data. So visualization is another way of big data. And then the last one obviously is the value part, okay, that we have just seen, that what value your organization is going to, or what benefit you are going to derive out of this big data, right? Okay. So let's come back to our DF, right? Now, how is big data actually used? Okay, so we are having some use cases now. Okay, small examples. How is big data actually used? So the first example that we take here is better understand and target customers. Okay, so to better understand and target customers, companies expand their traditional data sets with social media data. Right, so they are spreading a lot of information, a lot of publicity is there. Branding is there, so that we can get a good picture, of customers, you see. So we do good branding and we target customers with that branding. Okay. We understand that a special segment of people are going to buy a special uh, thing, like a category A thing is liked by, say, customers of a specific region. So we target them. We post them messages, we post them good advertisement sort of things, and then we give them some initial discounts. That is a strategy in today's world. And once customer gets accustomed to your products, then you can just increase your revenue, right? The second is understand and optimize business processes. Okay, so we see like what is the requirement of the customers. So based on that, you can pile up your stocks. Okay, so you can just check that, like you can predict something that in this month, say in the month of August, people bought a specific item. A lot of people bought this. So next year, you see, next year again in this month we are going to stock up this thing. So it goes like this. It's a long process, but then you keep on optimizing it as per your business process. Okay. Then improving health. Okay. So it big data analytics, enables us to find new cures and better understand and predict disease patterns. So again, data is there, analysis would be there, and predictive analysis would be there, like based on some data set which is about a specific disease. We see the symptoms of that disease, how many people had what sort of symptoms. Then we predict that if you have this symptom, most probably you are having this particular disease. Okay, so based on that, we can predict epidemics also, right? So you see a lot of this activity, that is improving health, is currently going on in this COVID scenario. A lot of research is going on by analyzing the data which we receive on a daily basis. This is very important, right? So example 4 is improving security and law enforcement. Okay, that you all know, how we can detect cyber attacks, how we can foil terrorist plots. Okay, and police is using big data tools to catch criminals and even predict criminal activity. Okay, and credit card companies, they are using it to detect frauds. Okay, very important. So all these things are around us. We have either seen it or we have experienced this thing around us. So big data is actually helping improving security and law enforcement. Then another one is improving sports performance. So you see sports people watching a lot of videos, analyzing a lot of data, weather data. For example, if there is some competition in a specific region, then they will be monitoring like what's the weather there, what's the wind speed. So all these things, So video analytics helps us in a long way to improve the sports performance. Okay. Then improving and optimizing cities and countries. Okay, so traffic system is one aspect of that, that we can monitor, how much traffic flow would be there, so we can use some divert routes for citizens. Okay, smart cities can also be, developed based on this big data. Okay, but you see, we have discussed so many applications, 6, 7 applications, so many characteristics of big data. Okay, but we can still be say that it is only just the beginning of a transformation. Okay, so we are changing things, but it is changing on a daily basis. But the applications of big data are endless. Okay? There is no end to it. Okay? All right. Now we'll again discuss some use cases of big data. The work that we are going to do in our big data analytics lab. So we are going to discuss this big data analytics lab with subject code ACCS 16508. Now these are the software that we need to install so that we can get kicking with the Hadoop and Pig and other ecosystem components. We need to install Oracle VirtualBox, uh, build 5 for 32-bit systems and build 6 for 64-bit systems. That's important because 32-bit systems don't support build 6 and onwards. And then we need to install Ubuntu 16.04 or Ubuntu 18.04. LTS is long term of service. Both the versions are stable. I'll be installing Ubuntu 16.04. You may install 16.04 or 18.04. You may install it either by dual booting your system. That is, on one partition you can have Windows and on another partition you can have Ubuntu 16.04 or 18.04. Or if you don't want to dual boot your system, you can install Ubuntu 16.04 in Oracle VirtualBox. So what I'll do in this video is I'll tell you how to install Oracle VirtualBox and within it how to install Ubuntu 16.04. And in my subsequent videos, I'll be discussing the installations of Hadoop 2.8.3 and Pig 0.17. So first of all, we must download the relevant versions of VirtualBox. So you can write here VirtualBox, build 5 or 6, whatever is a requirement for your system. So for old builds, 32-bit systems, we can go with VirtualBox 5 and onwards. So once you download on this thing, then you can click on Windows hosts, right? And you will be getting a file, this file VirtualBox 5.2.44, 105 MB file. I've already downloaded it, so I'm not downloading it now. You may download it by clicking on Save File. And with that, you must also download the extension pack of VirtualBox, which is necessary for efficient working of the VirtualBox. It's a 25 MB file, so you can again save it on your computer and then you can run it later on. Then another thing that you need to do is you need to download the Ubuntu 16.04 or 18.04, whatever is your requirement. So just click on this first link and then you can locate your 32-bit system or image or a 64-bit image. I'll be looking for a 32-bit image. I think it's here, Ubuntu 16.04.6 desktop i386.iso. So this file, I can click it and download it. I've already downloaded it, so I won't be downloading it. So next, what you can do is you can click on your downloaded files to install them. I've already installed Oracle VM VirtualBox, and after that you must also install the extension pack. Okay, once you've done that, you can start the Oracle VM VirtualBox. Okay, and within it you can create a new virtual machine. You can name it as, you can give it any name. So I'll name it as UBU 16.04 and I'll pick up Ubuntu 32-bit from here. Click on next. Just don't change any settings out here. Just click whatever is available on the screen and finish this process. Now this has been configured. You just start this virtual machine. It will ask you the location of your image file, right? So I've stored it in D drive. I'll just pick it up from there. So this is my image, Ubuntu 16.0. This, and I'll open it and I'll start the virtual machine. So this will start the installation of Ubuntu 16.04 in my system, in my VirtualBox. So The installation process has started. So let's wait for on-screen instructions. So it will now ask you either to try Ubuntu or to install Ubuntu. We'll go with the installation of the Ubuntu. Yeah, we'll click on install Ubuntu. Then we'll click on continue. Then we pick up this first option, erase disk and install Ubuntu, and we click on install now. And then we click on continue. Now it will ask for a few things and then it will start copying file and installing the operating system. So let's click on continue here. Continue again. Then we can give the name to our computer. So we can give it a name as Ajay Sharma. Okay. Here I can give a shorter name, say maybe Ajay. I give a small password and then require my password to log in. Let it be checked and then click on continue. So now you can see that it is copying files. Okay, it will take some a specified amount of time, 10-15 minutes to install. So I'll be giving my inputs wherever required. Otherwise, we'll just watch this installation. So we can see that it's almost finished copying files. Once done, it will start installing the Ubuntu 16.04. Now it's installing the system. That will take some time. So my dear students, this is the first step. You must install the Ubuntu 16.04 or 18.04. And then on top of that, we can install some latest version of Hadoop and Pig. And when we install Hadoop, the HDFS is automatically available, the Hadoop distributed file system. And we need to install additional components, whichever we would like to work with. Either it's Pig, Hive, Spark. We can install all these ecosystem components, but the HDFS is installed automatically once you install Hadoop. I'll be sending you a a list of complete list of steps about how to install Hadoop. It's a lengthy procedure, but very simple. You just need to follow the steps that I will send you, and you would be able to install Hadoop. Now we can see it is configuring hardware. And once everything is done, it will just uninstall the files, the installation files, which are no longer required. That would be the last step. Removing installation triggers. So yes, and we can install further Hadoop and Pig and other ecosystem components on it. So it is saying, please remove the installation medium, then press enter. We were using a file, so we don't have any installation medium here. So I'll just press enter. So now it will start Ubuntu. It has been installed. Now it will start the Ubuntu 16.04 operating system so that we can use it and we can install further Hadoop and Pig and other ecosystem components on it. The desktop is there. What you can do is you can locate the terminal, okay, and you can put it here. Yeah, we'll be using a terminal a lot in our Hadoop. So that is, how we can install Ubuntu 16.04 on our VirtualBox as a guest operating system inside the Windows operating system. And that's all for today, my dear students. In my next video with you, I'll discuss how to install Hadoop on Ubuntu 16.04. So till then, keep watching my videos. Thank you very much. So I hope the process was clear to all of you. I'm just so now we are going to discuss about some facts, need to know facts about big data. This is important because if we are going to work with something, if we are going to create something, analyze something, predict something, we must know some basic facts. Okay, that's what we are dealing with. What is big data? Simple things. Every 2 days, we create as much information as we did from the beginning of time until 2003. We just saw this thing, right? Uh, on a daily basis, we are generating a large amount of data. And over 90% of all the data in the world was created in the past 2 years. See, very important fact. So I think this book is written around 2014-15, but the scenario is still the same. We are generating so much data, so much data. Like it's difficult to imagine like what we are creating, but we are creating and we are dealing with it. It is around us. See the amount of data we are expected by 2020. Now we are in 2021. So 3.2 zettabytes to 40 zettabytes. 40 zettabytes is a huge, huge amount, right? The total amount of data being captured and stored by industry doubles every 1.2 years. This is interesting. Every minute we send 204 million emails, generate 1.8 million Facebook likes, 278,000 tweets, and upload 2 lakh photos to Facebook. This number must be doubled or tripled by now. I think this is an old book. Google alone processes an average of 40,000 search queries per second, making it over 3.5 billion in a single day. You see, you just write Google and you search for something and you get the results. Okay, but just imagine how Google is managing it on its servers. Okay. See now the YouTube scenario: 100 hours of video every minute. You know, every minute you are uploading 100 hours of video. This number must be very very high right now. Okay, and it would take you around 15 years to watch every video uploaded by users in one day. So much information is there for you to see. Okay. See, if you burned all the data, this is very, very interesting. If you burned all of the data created in just one day, if we see the data created in one day, if we just store it or burn it into DVDs, you could stack them on top of each other and reach the moon twice. Not even once, twice. So that is the amount of data that we are talking of, the big data. Okay. This company AT&T is thought to hold the world's largest volume of data in one unique database. Its phone records database is 312 GB in size and contains almost 2 trillion rows. See the amount of data that this phone company is. Okay. 570 new websites spring into existence every minute of every day. This number would be again higher, I suppose. Then 1.9 million IT jobs will be created. Yeah, so many jobs are being created, and then there is a recession. So that's a fact which is varying. In today's data centers occupy an area of land equal in size to almost 6,000 football. Okay, this is another the data centers concept. Now it's it's working from home, so data centers are still there, but yeah. See, this is important. One thing I told you in yesterday's lecture also, this is something that you can work in future. This is a good work as a career option. The sentiment analysis is going to stay for a long period of time. Okay, so companies, they're using Twitter to measure this sentiment analysis, the mood of the people. You know what they're going to buy, where they're going to live, where they're going to travel, how they are going to travel, what they are going to eat, which political party they're going to vote for. That is the sentiment analysis. And the just by analyzing the tweets on a daily basis, you can measure that sentiment analysis very easily. So another fact for you, okay, internet traffic like it is increasing every day. So Hadoop market, Hadoop is like in many companies, multiple companies, they are having this Hadoop in one shape or the other, and it's got a huge market share also. The number of bits of information stored in the digital universe is thought to have exceeded the number of stars in the physical universe. See, interesting fact. You can take a screenshot. That's good. Since you're going to learn this big data, so you must know, what sort of thing you're going to deal with. And it would be there with you once you study, once you leave the studies, you finish your studies and you go on for a job. Computer science people would be flooded with this thing. They would be dealing with this thing in one way or the other. Okay. Smartphones, are in demand. The internet things, like everything, we want data from everything, from our washing machine, from our, we need to control our ACs while sitting at office. So many things are there. So a lot of data is there. So this the RFID tags are there, right? Okay. So another fact for you to predict crimes, before they happen. This is the thing which is happening in today's world. You can predict crimes. Okay. So a predictive policing trial, like you can identify areas which are prone to crime with the help of this big data technology. Okay. Healthcare also is having, is improving day by day with this data analytics. Retailers are increasing their profit. Okay, you see, like they are just branding, then they're selling, giving discounts, sending things to people. You can get everything sitting at your home, and that too very fast. Okay, and this industry is really booming right now. Okay, all right. So I think that's all for today's lecture. Okay, I'm going to end this video here, and we'll meet in our lab next, and we'll see the installation of Hadoop. Okay, and if possible, I'll install Ubuntu also for you in VirtualBox if required.